of material dealing with a lot of mathematicals. So I'm sure you really need to exercise on the some question problems. So that's why I give you many questions. And this is one type of tutorial. I have another set of tutorial I've already shared in ITEL. Ada siapa sudah tengok? From ITEL, I've already shared the set of tutorial module. Ada. Okay. So I think the 12th question over there. But there's no marks on for that tutorial module. Okay, just part of for your exercise. If you done that, and then if you need the solution, you can see me or we can discuss the which question that you need to what we call as more you don't understand. Okay. So yesterday we have 5 questions, kan? We have already go through, and then you are do it in a group. So hopefully during the group you have made some discussion on which question that you some of your member probably not understand the question. So my target and my reasons to do the group member team is because you need discussion among your group so that you can understand better lah, and you can discuss among you. So for the first question, okay, so this is the first question that I got from the textbook, our reference book. Sekejap ya, macam dorang datang masuk. So here is the solutions. So yesterday, there's a lot of student getting macam terbalik kan. The answer for this smaller diameter is for BC, and you got AB, but you got the big diameter for the section of BC. But if you look again my slide, if you cut one section, meaning that this section only dealing with 30 kilonewton. Okay, but if you cutting through this section means that you have to have these two forces into this section. So that's why this rod AB will include both of the forces 40 kilonewton and 30 kilonewton. So rod AB, okay, I've seen some of your answers macam terbalik. Okay, so make sure that you can revise again your answer, but no need to give back to me the correct answer. So you have to learn your mistake from that. So the road AB, so we cut from here. So meaning that we have two forces applied to this road. Okay, so 40 plus 30, so it is equal to 70. This is quite because what I show you, we have to forces going down, we assume that in equilibrium mass equals to 0. So you have to do some equation like that before you come into this solution. Kejapnya macam ada masuk. Right. Okay, so here, so first you have, because here we don't get the value of diameter for each of the section. So we just use the formula of stress, which is sigma equals to force divided by the area. So the area, we know the formula for rod because it's circle. So pi d square over 4. And then we can have the simplified form of sigma AB equals to 4p divided by 4d square. Okay, from here, because with the value of d we don't know, so p we know. So all the parameters that we know put into these equations, and lastly you will get the diameter for D1 is 22.6 millimeter. So the rod BC, because you cut here, Okay, you cut here, so means that you have only one axial force at this section, which is 30 kilonewton. So similar type of step. So you get lastly for diameter, BC is equals to 15.96 millimeter. Saya dah check 1, 2 group. So you macam terbalik. It's clear. You can interrupt me if you have a question.
Sorry, Doctor.
Yeah.
Are you sharing your screen right now?
Oh, yeah, saya tengah sharing my screen. Ya, kenapa tadi ada saya tanya tadi nampak screen? Awal tadi. Window is. Okay, ni nampak?
Okay, Doctor, nampak.
Alright. Then this one. What I explained you just now is your solution terbalik. Root AB, you using the solution for root BC using the solution for root AB. So you need to check again. Because this is the similar things exercise and sample same question set that I gave during class. Okay, so revise again lah your answer. Okay, for the second question, this is to get the average normal stress. If they this question have give you 2 diameter for both section. So the using the same formula, okay, you get the force rod AB, okay, with total of 40 plus 30 kilonewton and the area of the rod AB, and then you calculate the stress, okay, normal stress. Average normal stress or normal stress from the question is the same. If meaning average normal stress means they have more than 2 members, so they call as average normal stress. So here rod BC, so the same formula applied for rod BC, but the force is only used for 30 kilonewton because we cut midsection over here. So we get F equals to 30 kilonewton. So the A is using the diameter for D2. Okay, lastly, you put all the numbers or the value that you know inside this equation. Lastly, you get the stress of at rod BC is 42.4 megapascal. Okay, and then this, kejap, kecil. Okay. So this one, because it's used English formula, so keeps or pound per inch. So he also solution for in terms of the unit lah. So these two cylindrical or the same things cases as from previous question, only that this have two forces applied on this section. Section D. So first things you have to calculate its diameter, area for each of the section, and then we don't know the number P. The P value we don't know, right? And you put all the stress, put all the value together with the unknown parameter inside this equation. So the stress for AB is equals to this 0.313 31831 P. And then if you have cut from the midsection of BC, so calculate same thing, calculate for the area for this section. Then check for the stress at BC. And we know that this is having two loads force applied to the midsection. Okay, so there are 2 times 30, and then you have to minus P because it's in the other direction. So divide by the total area of BC, and finally you will get this sigma, this equation for stress BC. And then here, same magnitude. Okay, compressive stress, tensile stress in B is the same magnitude, means the same value. For rod BC, so sigma AB is actually double from the stress BC. It has the same. So 0.313, this one will be equals to 2 stress at stress BC. When you solve this equation, you will get the P is equal to 28.2 tips or pounds per inch square. Then here is the fourth question. Okay, knowing that P with given the P is known, okay, which is equal to 40 pound per inch square. So you have to determine the average normal at this section. Okay, the same set of question. This is already give you the value of P. Okay, just put the value and using the same step, building the area of both the section, compare with the section, as value, and finally we get the plus value for both to be end. Okay, boleh. Your P and yeah.
1.3. Still magnitude.
Oh, the same magnitude. It means y is double.
Yes.
So determine the method of force free, which is the tensile for both the same magnitude tensors and plastic inverters. Uh, we already have double. So we had this direction. So we double this. Then this is this direction. As you can those money. However, when we look further, the rest of the why is that this ta ta. Again, this question. Right? This is up for free. So here, the P start differentiates. And then you will get the stress at section every. The fifth question. Fifth question. This is dealing with uh, bearing stress, right? Shear stress. I mean, the largest like to the shearing stress. Okay, so here is dealing with the bearing stress. So we have both load, steel rod gets supported by an aluminum. So here load is aluminum plate. Here this is steel plate. Right, or by aluminum plate. Okay, this is aluminum. The blue color is aluminum. Plate into 0.6 diameter hole in this. The hole um, P is applied. The steel rod. Smart steel. And then knowing that the shearing stress must not exceed. So you have to make sure that this shearing stress will not exceed 18 pounds per inch square or KSI in the steel zone and then KSI in the so because we have this road and for shearing stress, normally we have having the shearing stress over this area for this aluminum plate. Okay, and then we have shearing stress also at this steel. Okay, saya confuse ni. Yang ni steel ke aluminium? I think this is the aluminium, right? Okay, for the steel, so you have to know that this is should not exceed the uh, 18. Okay, 18 KSI. Okay, 18 KSI is will not be exceed. So we have known that the area for the steel. Okay, so here is the steel. So we have to know that what is the area that having this shear stress. Which area that have the shear stress. So within this hole, so we have this area of that have the accumulate some stress in that area. So the area, like I told you, this is the cylinder shape. So the area of where the shearing stress occur. So we use the cylinder type of equation, which is pi times the d depth of the steel times the sorry, d is diameter of the steel times the t thickness. Okay, thickness is 0.4, which is this one now. Confusing. Okay, and then you get the area of steel. And then you use the formula for shear stress, which is tau equals to force divided by A, or tau equals to V. Okay, shear stress divided by the area. And then you have to, because this is not exceed, right? 18 is already given to you. So the forces must apply to the steel that not exceed 18 pound per inch is 13.57 kips. Right, this is the force. And then for the aluminium, is the area over here. Okay, the length, total length covering this area. Pi times the diameter of the aluminium. 1.6 times the depth of the aluminium, which is 0.25. So this is the maximum ones lah that having the shearing stress, right? And then the area is this 1.2566 inch square. And then you calculate for the shear stress. And this one, you just use put all the value for the aluminium, which must not exceed 10. So the forces that should apply to this plate for aluminium, the maximum is 12.57 keeps. So you just limiting value is of P is the smaller value. So you just must use the force, the maximum is 12.57 keeps. Jadi macam a bit confusing like this question, right? Okay, never mind. Oh, so this is another set of question. I think I have four new sets of question, but you can go through because I've already provide you the question and the answer for each of the question. This is for question 1.1. Okay, this is you have to know the normal stress. Okay, normal stress in the column that not exceed 30 KSI and the bearing stress in concrete foundation. Okay, and then this is another set of question where you need to check and calculate for the bearing stress for this axial load applied to a short wooden. And then this is another where we have dealing with this, we call a rope. Okay, so you have to check and you have to calculate the bearing stress in the member of this rope. Okay, and then this is a quite complex of solution, but you need to use your imagination. So how can we put this figure into the simplified form? Okay, this is when you have to refresh back again how you apply the mathematics on the degrees, right? For example, if we take this rope as this AC, okay, AC is this one, and then up to the B is the point of over here, and then you go. This is a polar. Take the polar set at A. So here give theta is equals to 40 degrees. So here is the 40 degrees of for the theta, the value of theta. And because the total value for the straight line over here is 180, so that's why this is equals to 140 degrees. And then this is 40, and then because of this one will be equals to this plus this kan. You know, previous mathematics during your STPM or SPM, you must know the rules of how to get these two you to sudut di sini. Okay, both of place lah to 40 degrees, meaning that 40 is equals to this one plus this one. So you have to divide by 2, this is 20 degree and 20 degree. Alright, from here, you can check, you have to apa ni, learn for yourself. Okay, look into this question. If you have a question, so you can ask me lah how this the solution is like this. So any set question you can ask me later on lah. Okay. So this is the solution. So that's all. That's all for the tutorial actually. So I don't want to really stress you on focusing on my explanation, right? So you can learn for yourself based on the question that I gave you. Okay, this is for the self-learning lah. And then another thing is actually for online, 30 minutes is equals to 1 hour because normally student cannot focus if you stress more time during the online lah. Okay, so another things that I would like to apa ni show you or sharing some info lah with you guys. Okay, before we go to this our class schedule, okay, do you have any question? Or do you prefer I explain each of this question ataupun kamu suka belajar sendiri.
For me, I rather have you explain the question.
Oh, suka saya lagi explain lah. Alright. Okay, before we go to the last set of question lah, one last question lah before we end our tutorial. So here, I've already changed a bit, especially the weightage of your carry marks. Okay, for the test one, previously I said 15%, now I reduced 10%. And then test two also the same weight, which is 10%. So because I would, your exam is 40%, so plus 10 plus 10 is 60% test. Means test without the books lah. So the assignment will be 40%. Right, so I will do the set of question for this assignment 40%. Mostly is a group work lah. So nanti saya akan will explain that during our class next week. Right. Alright, so we go back to the question, the last question. I think yang tu paling susah lah. So normally the test would be something like more complex, more complex set of question lah, right? Sort of like this, sort of like this, right? Within 1 hour, so you have to solve. Kena keluarkan something the info from this set of question and you draw. Kejap, saya tak boleh share yang tadi pula. Kejap ya. Mungkin kena buat macam ni kot. Mana tadi? Screen, no. Windows. Alright. You can see my screen?
Oh yes, doctor.
Is it in a presentation punya ni kah? Mode kah? No. Is it a slideshow or not?
It is.
Oh, right. In a slideshow lah. Okay, so alright. I think the most difficult question is this part lah. Alright. And yeah, I think you can just go learn for yourself. And then this one also. I give you all this question and in the ITEL, so you can get from the ITEL lah later on. Okay, so here when you have this look at this set of figure, so you have to transform into diagram like this, okay, to simplify this into this, but you have to use your imagination lah, right? Of course. And then this is the question that you need to what is the info that you can get from this question. So you read the question knowing that the theta, so here you already have theta over here is 40 degree, okay, and the P is over here 9 kilonewton. Okay, and determine A, the smallest allowable diameter of the pin at B. So this is the question needs you to calculate which is the diameter at pin B. And if the average shearing stress in the pin is not exceed 120 megapascal. Okay, so you have theta 40 degree over here. So transform into the simplified form of diagram. So A to B is 750 millimeter length. And then the same length also in the B and C. And this is 140 degree and 20 degree for each of the point at B and C. And then if you transform it, you include the value of P, okay, at point A. So simplified form for this one. So you have this 50 and 20, but from here, FAC, the forces of FAC over here. Kalau kita ambil this side only. So this one will look, the name for this part is FAC. So because it is 180 degree, right? So 180, which is 180 minus 50 plus 20. So we'll get the degree for this side is 110 degree. Okay. And then this force is FAB. Right. The arrow, why is show like this? You have to look again your punya previous SPM kan. The rules of thumb. Okay, which arrow should be goes over here or over here. So in order is in equilibrium, so the arrow should be in the direction of in equilibrium. You kena buka buku balik lah. Right. Make a revision on this part. Or arrow and then the degree one. So if you put in the overall what we call as a overall overview, which include the P value, okay, the value of P, which is the force, and make it in a one big picture. Okay, here and then goes to here. So can have P and the road is FAC and the FAB. FAB is this one lah. So transform into that. So you can have this simplified form of diagram. So 110 degree here. Okay, and then you get this is actually the FAB. To that direction is 20 degree. But over here is how much? Okay, because 110 plus 20 minus 180. So you'll get 50 degree. No, this is physics lah. Physics. Yang saya ingat masa SPM or matriculations lah. I think you learn about this. Okay. Equation and how to transform this vector and degree form. So we get all this P and then the tie or the rope and everything we have already put into this term, okay, force triangle. So FAB and FBC. Okay, so the law of sines applied to force triangle. So we have P forces divided by sin 20. Okay, because it's this is the rules of sine cos. Okay, sine cos rules. P divided by sin cos t sin 20 degree. Okay, equals to FAB divided by sin 110 degree equals to FAC divided by sin 50 degree. Okay. So FAB will be equals to, if we just use this equation lah, you can use this one equals to this one or this one equals to that. Either way, you will get the same answer. So this using this equation lah, P divided by sin cos 20 divided equals to FAB divided by sin 110 degree. So because we need the forces at AB. So forces at AB is equals to P times sin 110 degree divided by sin 20 degree. Solve this equation, then you get the force at AB is equals to 24.733 kilonewton. Okay, so we get this value force, which is the force at AB. AB, which is at this one lah, the puller. Tak ada pula nama di sini kan, benda ni. FAB forces applied is equals to 24.73 kilonewton. So after you get the forces at AB, so now you can go to the first question, which is determine the smallest allowable diameter of the pin at B. Okay, what is the smallest diameter at pin at B? So here tau equals to forces AB divided by 2AP. Okay, now we get 2 AP because of there are two area covering to this area lah. I think so. Ya kan? Pada pakai 2. Sekejap ya. Yeah, because they are bearing stress kan. You know we have double bearing stress, single bearing stress. So this is using the double bearing stress. So the area will be you can go to my slide previously, slide lecture class. So ada kan saya simplified form of if we have double bearing stress. Okay, so that's why the area is now times 2. So the sharing stress for the pin at B, point B. So because we know that the FAB is previously already calculated, and then the diameter that we don't know. So the value for this diameter, you simplified this into this form, and then all the values that you know put inside this equation. Okay, then the diameter is equals to this. Double d square, diameter square equals to 131.18 times 10 to the power of minus 6 meter square. But this is double, so you have to square root it. So lastly, you will get the diameter for this pin is equals to 11.45 millimeter. And then the second question, the consuming average member AB at B. So the corresponding bearing stress. So the bearing stress AB, so this one only have T, the thickness of the point B times the diameter, diameter of the pin. So the area is this one at point BAB, at point A, sorry. Oh, bearing stress in AB at A, at B. We have a stress member AB at A. So, dia punya ni salah ni, typo. So, this bearing stress, okay, the forces divided by area. So, we already know the area, and then the force AB, you already calculated. So, the total of bearing stress at A at point B is 134.9. Now, the corresponding average bearing stress in each of the support bracket at B. So, because here support bracket, so bracket is over here lah, two brackets over here. So here divide by 2. So half bracket we goes here, and then half of the bracket we goes here. So the forces will be divided by 2. So this is to have the value of the area at this point. Okay, and then times the diameter. Okay, it's 11.45. And then calculate for the bearing stress at the support, which is 2. And then you have to divide by 2 from the forces value. So the area, divide by the area. So you will get the average bearing stress at the support bracket at B is equals to 90 megapascal. Quite complex, right? I think from the tutorial
Yes.
question ada satu tu yang macam ni, lebih kurang. Ya, tadi ada soalan? Quite confusing. I think this one you are more to physics, mathematics. Kena revise balik lah. Okay, then dia punya some of the question lah. Especially the vector. This one. I'm sure the boys mungkin can catch up. I think the girls lah. It's not easy to imagine how to transform this figure into this form. Right guys? Right girls? Dulu saya macam tu juga. Tak tahulah kenapa. Probably perempuan imaginasi kurang. Less imagination. Okay. Any further question? You can do exercise. Okay, try practice. And from the question I gave you, and then check each of the answer. And then if you like further explanation, so we can go discuss again lah during class. Okay guys, boleh?
Okay, good. Okay, okay,
Yeah.
doctor.
Okay, doctor.
Alright. Okay, so that's all for tutorial. Now I will give you the link for today's attendance. Chat. Okay. Okay, here's the link for attendance today. So that's all for today's class. So I see you again next week at BT6. Assalamualaikum. Bye-bye. All right.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
All right.
Thank you, doctor.
Thank you, doctor.
Okay. Thank you, doctor. Okay, sama. Thank you, doctor.